Okay, before we cover on the new information for the day in terms of lesson 1.1, let's review some fundamental skills. Make sure we at least look at it. Don't forget, whenever you do multiplication, but the first thing we do is line them up. That you freeze on the 2, as I like to say. You kind of ignore the first number, so you focus on the 2. Doing 2 times 2, which is 4, 2 times 3, which is 6. The trick here is making sure that once you're finished with the 2 that you bring down 0, and that you then freeze on the 1. So 1 times 2 being 2. Sorry, my pencil's going to roll. 1 times 3 being 3. And then you add up those columns or those rows to get your answer. 4 plus 0, 4. 6 plus 2, 8. Bringing down 3 and getting the answer of 384. Now on Math Excel, it's going to be important you understand that you only need to type these numbers in. If something carries, whenever you're doing that, you don't need to put that. You just put the 64, the 320, and the 384. But in order to get that right, my suggestion to you is that you actually do it on paper first before trying to do it on a computer. Now, when you get good, feel free to do that. But initially, I would probably do it on paper. Second question. This is a percentage problem that we've talked about. You take a quiz and get 15 out of 18 questions right on a quiz. What's your percent score? Well, remember that this is going to be a fraction. And the fraction is based off of how much we got right out of the total. That what we want to do now is actually do 15 divided by 18, because that's what it is. 15 divided by 18. We write down the first 3 numbers, which is 0.833. We then adjust it into a percent by moving the decimal 2 spots, which makes it 83.3. And the last thing we do is ask ourselves if this number is strong enough to bump it up, which it is not, so it's just 83. And so that would be your answer, which is 83%. Again, in terms of the Math XL, that's the only number you have to type in. I think I already have the percent symbol on there already. The next thing is the final game, or final score game, which is where you pretty much ask yourselves one of 2 questions. How much did the team win by, or how much did the team score? Well, in this case, because both teams scored, our question is how much did the black team win by? And so therefore black won, of course. And they won by, well, if you're looking at this, you would actually subtract, because again, you want to know how much they won by. 7 minus 4 is 3. Or you could ask yourself, how much more does white need to match what black has? And then on this one, again, when it's the same team scoring, this is where you ask the other question, which is how much did they score? Well, if they scored 2 in this set, scored 5 in that set, they scored 7 altogether. So those are your 2 trains of thought. If the scores are different, you subtract them. If the scores are the same, you add them together. All right. And then the last one is the rename of the fraction. Whenever you do that, the first job you have is to pretty much imagine. Again, you want 42 as your denominator. So your job is to figure out what you had to multiply 7 by to make it 42. And so what you do is you actually do 42 divided by 7 to find that missing number. To realize that that number is 6, that means we are going to multiply this by 6, and 3 times 6 is 18. I don't know why I wrote 16, but again, 3 times 6 is 18. And so your answer would be, sorry, you can't read that, 18 over 42. And that is all you have to do on that process. Again, it's just making sure we start working on these things, because we are going to build on these skills as time goes forward. So today what we're going to talk about is a distributive property. In the distributive property problem, there is typically one value outside the parentheses that is what we call distributed to the inside values using multiplication. To make it more understandable, I like to think of it as though the inside values are friends already, and the outside value is someone who wants to introduce themselves to them. So a quick example, if you see something like this, in this situation, Tim and Geo, and I use small names because I didn't want to have to write long words just to get this done, but Tim and Geo, because they're in parentheses, already know each other. And try to adjust your thinking for this, because if you adjust your thinking, it makes it easier to understand. These 2 already know each other and they're friends. This is someone who does not know either one of them, so what he's going to do is introduce himself to Tim. So Sam will meet Tim. And again, I use parentheses to show the introductions. And, which means there's going to be another introduction. Sam will meet Geo. And so with that said, that's all you have to do. Now, here's what you have to be careful about. Don't try to take shortcuts. Don't try to say, well, I don't like the way that looks, I'm going to do it my way, because again, if you do not show the what I call the meetings on MathXL, you're going to miss it. So make sure you're looking. You don't have to copy it, but make sure you're understanding. You must put Sam in parentheses next to Tim. That shows that they met. You must put Sam in parentheses next to Geo. Now, why don't Tim and Geo meet? Because as I said about the parentheses, they already know each other. All right. Same thing. Wes on the outside, Ben and T. I just had, finding 3-letter names is kind of tough after a while without getting ridiculous. So Wes with Ben and Tia. So we're looking at Wes meets Ben. And, which means plus, Wes meets Tia. And again, that's all you have to do. So please notice again, our meeting uses parentheses to surround every person in the meeting. If you do not use parentheses around the numbers that we're going to be working with, it's not going to count. So also notice that we use a plus sign to attach the meetings. That's going to stay pretty consistent throughout the things we do. The same process holds when we work with actual values. Let's just look at our examples real quick and wrap this up before we get to work. So good practice advice, again, in order to ensure you learn to be more independent, make sure you copy these examples that I'm showing next. Your MathXL homework will require you to show your answers exactly as they are shown. The frustrating thing that your teachers end up with is whenever you get a video like this that's telling you to copy the notes and use them on your homework, you get frustrated with us because you can't get the right answer, and then we ask you for your notes and you don't have them. So please make sure you try to write this stuff down, so when we ask for your notes, you have them. We can help you learn to use your notes to get your answers right. So again, if you do not have your notes when we ask, just understand we don't have to really answer. We can send you back to the video to copy this that you should be copying right now. But again, with this the way it is, imagine 5x and 4 already know each other, and 6 wants to meet 5x, and 6 wants to meet 4. The difference is, now that it's numbers, we can actually do this, and the parentheses actually means multiplication. So when you do 6 times 5x, you multiply 6 by 5, which is 30, and bring down the x. And then when you do 6 times 4, which is 24, you just bring down 24. That's all. So this is, on your MathXL, going to be the first box that you show. This is going to be the second box that you show. If you want to put boxes around this to make sure you understand, that's it, but that's all it's asking you to do. So please don't say, I don't know how to do this, it makes no sense, and then have no notes, because I'm telling you right now, this is exactly what you have to do. 9 times 3k minus 7. Again, these two know each other already because they're in parentheses. Be careful how we write this. You would say that 9 meets 3k, and even though that's a minus, we will always use a plus, as it said. But the trick is, when this happens, you'll have 9 meet what we call negative 7. 9 times 3k, again, you'll know that 9 times 3 is 27. I'll let you figure that out or get used to that on your own. I won't waste your video time doing that. But here's the trick. Don't put a plus, but look at this. Whenever you multiply positive times a negative, whenever the signs are different, we'll discuss this a little bit. I think it's on the next video. But when the signs are different in multiplication, your answer is negative. So 9 times 7 is 63, but there's a positive 9 and a negative 7. So it's going to make a negative 63. All right. And again, the beauty of MathXL is you can miss your problem 3 times before it gets frozen. So if you happen to miss it and don't know why, just ask for help before you get to your third miss. Otherwise, you have to start all the way over. 4 times 8m minus 1. Again, in this situation, these two are friends. So 4 meets 8m, and 4 meets negative 1. Again, always a plus to connect. Always leave that negative with the number. This here, 4 times 8 is 32. Again, bring down the m. And as I just said, when the signs are different, it's going to make a negative 4, not a positive 4. And that represents your second answer, or second box. So with that said, go ahead and go to your MathXL. Make sure you understand that when you log into MathXL, your login password is SE followed by your lunch pin. So whatever it is, if my lunch pin was 23598, I would put SE 23598. And your password is student, STUDENT 1. Not students, but this is your login, again, based off whatever your lunch pin is. and this is your password. If you have an issue, please ask immediately. Don't stare at your computer for 15 minutes. And then we ask what's going on, and your answer after staring for 15 minutes is, I don't know how to log in. I'm telling you right now. So again, make sure you understand how that works, and again, good luck.